the GPO from here on, and the tools and data that we have available. If you're not familiar with the GPO, we are within the state's Department of Information Technology Services, and for more than 15 years, the GPO has worked to make framework GIS data available to the public. It's the GPO's mission to provide geospatial information and capabilities to the benefit of all of New York. And so we know that people benefit from having the best geographic data, tools, and expertise. And so whether we're talking about making sure a pizza is delivered to the right address through the use of a geocoder, if a new business finds an advantage to locating in New York State based on the ease of parcel data investigation, or a 911 call gets routed to the right location, we want to be part of the data that goes into those activities. Over the past few years, the GPO has been working to freely release over 15 terabytes of framework data. And I just saw a message there that my screen stopped sharing. Just reloading it quick. So while that's loading, so we've been working to freely release framework data, and here we go. Here's my presentation again. And simultaneously, we've embarked on an initiative to build a catalog of web services that provide these framework data sets for public use in an efficient and flexible format. And so these are the types of initiatives that Sean and I are going to discuss today. So let's start with the data. This term framework data really means data sets that not only can be used by everyone, but more importantly, these are the data sets that are most commonly requested. You can think of them as the base data that you would want to display your business data on top of, providing a foundation for analysis and visualization. So the first stop in understanding what we provide is the New York State GIS Clearinghouse, which can be found at gis.ny.gov. And so I'm going to launch the clearinghouse here. And so you should be seeing what I'm seeing, which is the clearinghouse website. And right from the start, what you get is you get an interactive map of New York State. And what I can do is if I hover over the map, you can see the polygons change color, and you can see the pop-up for the county name come up. And what I can do is I can select one of these counties, and I'm going to select Albany County because that's where our office is located. And I can see the data that is available for that geographic area. What I can do is I can specifically look at the orthoimagery that's available. I can search for other layers of interest in the data set section, or I can look at outreach and try and connect with the county specifically if I'd like to do that. If I look at the data sets available, this way of searching for data is something that many of you or most of you should be comfortable with. You know, this is what we're all used to. When you have a clearinghouse, you can search for data by different types of categories. And here we have types of coverage that came up for that geographic area. So I could look at national coverage, etc. If I go back a step to the main page, I can also search by GIS Program Office area. And so the program areas type the groups inside our office, and these are the areas of expertise that we have. So if I select parcels, for example, I'm provided with the details on what this program has been up to, including information on which counties have made tax parcel data publicly available. I can look specifically at the New York State-owned tax parcels. I can get a look at the tax parcel centroid points. And this is a data set that I want to comment on briefly. Historically, this has been a method for obtaining statewide assessment roll data through the centroid point. But in a little bit, I'm going to introduce a new way that we've come up with at getting at this robust data set that we're very excited about. So as you expect a clearinghouse to function, this is the type of stuff that we're all used to. But I'm going to get into some advancements that we've made. So to do that, I'm going to back out of the clearinghouse for a second, and I'm going to talk a little bit about these program areas which I mentioned. So the GPO is comprised of multiple framework data programs, and these areas are responsible for maintaining, updating, and creating these framework data sets. And so our program areas include orthoimagery and elevation, covering things like LIDAR, digital elevation models and orthoimagery. We have a robust streets and address maintenance program with over 9 million rooftop address points. We have the civil boundaries, providing polygon boundaries for counties, cities, villages, and more. And we have the statewide parcels program, providing centralized access to tax parcel data for state agencies and the public. In addition, with these data sets, we support things like emergency preparedness and response through the state's Office of Emergency Management. We support the state's critical infrastructure response information system. We also support the state's mass notification system for weather, public safety, and health, known as NY Alert. And we provide GIS support for the New York State Police. So we have these program areas. And in addition to these program areas, we have Share GIS, which is our new mechanism for providing this wealth of data to the public. Share GIS is a GPO technical initiative to build a common geospatial services infrastructure for New York State. And so together, Share GIS and the program areas make up the GPO. The idea is that we have all of these great data sets in the program areas and this link to the authoritative data provider. And so what we're doing is we're getting that data over to Share GIS, and then Share GIS helps provide that data to the public. Now, the way we provide these data sets to the public is through map and geoprocessing services, and those are made available via Esri REST endpoints. So as Razi mentioned, I'm a senior integration specialist at the GPO, and what that means is that I often interact with programmers, developers, project leads, even less technical users to integrate services with web applications, to connect desktop software with these services, and basically answer the general question of how do I do this. So up top here you can see a link to the Share GIS production environment and a recap of the types of data sets you will find there. Don't worry, I'm going to go into this production environment in more detail in a little bit. But I want to make a note for developers that the format you're going to see for web services published by the Share GIS team will consist of URLs exposing REST endpoints from our ARC server environment. REST, or Representational State Transfer, is a software architecture style that defines a set of constraints that are used for creating web services. And we use REST architecture style or RESTful web services to provide this interoperability between computer systems on the internet. So if anyone is looking to develop against a non-production environment, please contact me and I'll get you hooked up with that. And so what I'd like to do now is I'm going to go over a few ways of interacting with these services and specifically talk about that new assessment role service that I mentioned, which is going to provide a perhaps unique way of accessing that robust tax assessment data set. But first, let me jump back into the presentation here and pose a little survey. Where's that link? Am I still in the room there, Ravi? Why can't I find it? There it is. Got buried. Sorry. So I'm going to pose a survey, and I'm going to ask, does your organization use web services in their mapping activities? Hopefully everybody can see the survey that's up there. Web services are a great way of getting at data, and web clients like ArcMap or QGIS have the ability to connect to these web services and get at this wealth of data that we have, which is it provides a really nice framework for that. So I'm going to give everybody just a couple seconds here more to provide your answer, and I see that they're starting to come in here. All right, I see that some are coming in. Most seem to be familiar and use them frequently. There's a couple that not so much, and I think this is a good representation. So I'm going to end the survey here, and I'm going to share the results. I apologize if a few of you didn't get a chance to. But you can see that, the results were starting to build, and we've got a good mix here. All right. So I'm going to jump back into my presentation here. And what I'm going to do is I'm going to jump back into the Shared GIS, the New York State GIS Clearinghouse, and talk about web services. All right. So on the Clearinghouse homepage, we also have this drop down for Shared GIS. And you can either get a little bit more of an overview of Shared GIS, or you can go into the web services section. And as I mentioned, web services are the way we want to get data into your hands. Because unlike traditional methods, web services remove this need for download, but they still provide you the analysis functionality you might be used to. So in addition to our offerings for the web services, we also have multiple web services hosted by various state agencies. There's also this set of New York State GIS Program Office web services, and you can click on either imagery and elevation or non-orthophotography. I'm going to let Sean talk about the ortho-related imagery and elevation stuff in his presentation. So I'm going to look at the non-orthophotography folder. And when I do that, I can see the composition of these map services. So for each service, what I can do is I can see a link to our production environment. I can also see that REST endpoint that I talked about for this specific set of layers, the civil boundaries. I can get some notes on that service, what it incorporates, as well as some information on, hey, this one's also available as a map service and not just a feature service. Okay, so for each service, what I can do is then I can click on one of these, and I'm taken right to the endpoint for that feature service. In this case, it's, again, the New York State Civil Boundaries feature service. I can see the layers that are available inside there. I can get there's also a service description of what's going on here, and I can see all the layers that I have available to me. If I go into one of these, I'm going to go into the county shoreline, which is just the New York State counties cropped to the state shoreline. Inside there, I'm able to get a description of the data set. If I scroll down, I can see the fields that are contained within this data set. And if I go back up to the top, I can also get a preview if I'd like with ArcGIS Online, which is a nice convenient method of bringing the data up nice and quick. You don't have to bring it in any of your software, but you can see through ArcGIS Online as the map draws here, I'm provided with a general representation of what it's going to look like. And if I click on any one of the features, I can also see what that pop-up information is going to look like. So that's a nice little tool to see if this is indeed the service that I want to be using before I bring it into my local machine. If I go back to that endpoint for the county service, if I go all the way down to the bottom, there are these Esri supported operations which I can look at. And the nice thing is there's just some added functionality to the service that you can use. What I'm going to demonstrate is I'm going to demonstrate the query tool. Now, the query tool is basically a way for me to enter in a coordinate, if I'd like, or a location, and get back what county does that point fall in. So that begs the question, where do I get my coordinate pair to begin with? Well, I'm going to jump back quickly into our services, and at the top of this page, you'll see the folders with something called locators. Now, the locators represent all of our geocoders that we have available. And depending on the type of address that I have, I'm going to use a different geocoder. Now, if I have a full address, I know the street number, the zip code and everything, I'm going to use this streets and address composite. If I didn't have the street number or the zip code, I might use the one below it. But for right now, I'm going to use the full streets and address composite. And if I go down to the bottom, I see the Esri supported operations that I have. Find address candidates means geocode an address to return a coordinate pair. Reverse geocode is the opposite. It means taking a coordinate pair and generating an address based off of that X and Y. Lastly, I have geocode addresses, which is the batch functionality for the case when I have more than one address that I want to do. With find address candidates, I can use either a multi-line approach to my address, or I can use a single line approach. I'm going to begin typing in the address for our office here, which will auto-populate because I've done it so much. And if I hit find address candidates, what I should see is a result pops up at the bottom with a coordinate pair for that address. In fact, 2 results pop up. Now, I should mention that the default for ArcGIS Server is a NAD83 coordinate system, which is why my coordinate pair is returning in this format. If I want to change the format of this output to something I'm more familiar with, what I'm going to need to do is I'm going to have to use this output spatial reference. And now, the output spatial reference is based off of a list of standardized set of identifiers for coordinate systems. It's the European Petroleum Survey Group that maintains this list, and this list is used by Esri in the Arc Server environment. So, for example, if I type in one of these codes that I know well, basically it's an identifier for a specific coordinate system. I can see that 4326 refers to WGS 84, the coordinate system. So what I'm going to do is, knowing that I'm familiar with this system, if I add the output spatial reference here, and I'm just going to go into my outfields and put a little asterisk in there, which means return all of the attributes and not just a few. If I hit that find address candidate button again, what I'll see is a coordinate pair that is in a format I'm more familiar with, more comfortable to the work that I'm doing. I can also see all of the attribute information, and it helps me discover why I got 2 matches. These locators refer to, these are the rooftop match that this first result came back with compared to a street segment match at the bottom. And so I'm going to go with the one that I feel is more accurate, and I'm going to take this X and Y coordinate and copy it off of the rooftop match. All right, so I've got my coordinate pair. I jump back into my services. I'm going to go to that civil boundaries county shoreline service again. I'm going to jump back down to the bottom to that query pane that I was in. And now where I have that input geometry entry point, I can just paste that X and Y, making sure that I add a little comma in there, making sure that I tell the server that, hey, this is a point, and the input spatial reference I used was that 4326, which represents the WGS 84 coordinate system. Lastly, I'm going to say, hey, please give me all of the outfields, or the attributes, with that asterisk character. And if I run that query, what I should see, as it runs here, at the bottom is I should see a nice result, which is going to be the intersection of this point with the county file, and I see that my location is located in Albany County, and I get the additional information for that county, such as the population, etc. And so this is what I was expecting, because that is where our office is located. So that's a handy little way of using the services together. All right, so now if I say I wanted to use those services inside of a mapping environment or a desktop tool that I'm familiar with. Well, here's what I have in ArcMap. So what you'll see is I've got some business data. These are some weather station points that I have, and if I identify on any of them, what we'll see is that I have a station name, I have a latitude, longitude, and then I also have a URL below that, which provides some more information if I want to go out to the actual station. But I'm not going to click that because it'll launch a new window. But I don't have any county information in there. So maybe, knowing that I don't have the county data set on my local machine, I could download it in the traditional format. Or in an ArcMap session, what you can do is you can connect to a GIS server through catalog. And so if I say add an ArcGIS server, and I'm going to use the GIS services available on that server, what I could do is I can paste in that URL for our production environment and say finish. And what will happen is over here in our catalog, I'll see that that server was added. And there's a little plus sign where I can expand, and I can get at all of the services contained in that environment. if I just drag and drop that civil boundary service, I can get back all of the information on all of the layers that are attached to that endpoint. It's going to spin for a second here, but hopefully it won't take too long. And so you can start to see the polygons drawing. I'm actually going to turn that off so it doesn't, so it goes a little faster here. Apologize for the wait. But what it's doing is it's reaching out to the server, and it's pulling back all of the information that's contained in there. And it's spinning and spinning and spinning. All right, while that spins, I apologize for that. I'm going to jump into, unless it's coming back here. Might have to reload ArcMap. All right, while that's doing that, I'm going to demonstrate QGIS, and hopefully that'll be ready by the time we get back. So the nice thing about QGIS is that with, I believe, version 3.4, they made a change. It used to be that you had to load a plugin for to bring in ArcGIS services. But now, just through their layer dropdown, there is an add layer availability. And what you can do is you can directly add either a ArcGIS map service or a feature service. So I'm going to choose the feature service. What I can do is I can establish a new connection, and I'm just going to call that my shared GIS test. And the URL is, again, going to be that production environment. If I say OK, and I say connect to it, no. Let me just make sure I type my URL correctly. Yep, I think I, give me 1 second here. Just missing a little bit on the end there. All right, so I connect to it. Now I see all of those layers that were available when I was connecting to the REST endpoint earlier. The nice thing is over here in my table of contents, I see under this ArcGIS Feature Server tab, I now have that connection. And if I expand that connection, again, I have all of those layers available. So if I click on the county boundaries, it should add that one in. I think I'm taxing my machine a little bit here. I apologize. Okay, so I'm bringing, that's my business data that I'm going to put on top of the county managers, and there we go. Sorry about the wait there, but the county has drawn, and I can perform my analysis based off of my business data and the underlying base data. Hopefully, if I jump, okay, I've jumped back into ArcMap now, and so that service has come up. I'm going to turn off several of these layers and just get the county boundary back in there. There we go. And so now that I have this combination of business data from my local machine and base data off of the server, what I can do is I can perform a query or a tool. I can run a script off of this information. I could do a simple intersect of the two, and using that tool, I could intersect my civil boundaries with my station data. There we go. And it's nice that I can drag in right from the service. I can drag in and populate the tool with that data. I can also bring in my business data, and I'm going to like any good cook in the kitchen, instead of running that tool right now and possibly bogging down my machine, I've already got one in the oven, so I'm going to just show the intersected data that I've already done ahead of time as it's reloading here. Okay, and now if I identify on any one of those points, remember before I didn't have the county data available, but I can look in and I can see now that I have the county has been added to my points. Oops, that's actually the county there. I didn't get a point. So if I get the point, all right, I can see that the county data has been added to my point in addition to my station name and all the other information I have it available. So I just wanted to demonstrate how this idea of bringing in data from a service can also be used to bolster the business data that you have. So if I jump back into my presentation here, all right, what I wanted to do is I wanted to talk a little bit about, I'd like to touch on the difference between map and geoprocessing services, because this is that new service I talked about we're really excited about is a geoprocessing service. And that might be something that folks aren't familiar with. You know, we have, with a map service, you know, this is going to be your map or feature services, your WMS, your WFS. And what you have first is your computer makes a connection with a server. So that connection is established. And this is achieved through a REST endpoint. This connection can be made to a folder that has a layer or multiple layers inside of it. After that connection is made, the layer information is then returned to your local machine. Now, through your desktop code or your software, you can visualize that information. And depending on whether you're using a map or a feature service, you have the potential to run additional scripts off of the service and using the data that you have locally. Now, for a geoprocessing service, again, that connection is first established with the server. If you have experience using a geoprocessing service in ArcGIS Desktop, you can think of a geoprocessing service as a toolbox that is made available from the server. Now, there can be multiple toolboxes on a server, and there can be multiple tasks inside each of those toolboxes. The main difference is that when you execute a task in a geoprocessing service, it executes on the server rather than on your local machine. This can be beneficial in many ways, including the fact that it can provide a faster result, especially if you're interrogating a very large data set, such as our tax assessment data. When the execution of the task is finished, the result is then returned back to your local machine, and now your interaction in your desktop software is going to be a little different. Rather than having a visualization of that service in your software, what you're going to have is an entry point where you're going to have a dialog box that asks for inputs, and then the results are going to be generated and returned to you. So what I'm going to do is I'm going to demonstrate the tax assessment service. That's going to be the last thing I go over before handing it off to Sean. But previously, it's important to know that previously this information was only available through those centroid points for a statewide data set. And so this work has been going on for more than a decade and was deemed to be a high wish list item. And one of the, it was even identified as a necessity for governments to effectively use and benefit from GIS technology. So if for one last time I jump out of my presentation here and I get back into ArcMap, okay, I'm gonna turn off my services from before, and what I'm going to do is I'm going to go over here in catalog and again look at that connection I made before. And inside that connection, I can see not only do I have the layers available, but I also have this New York State Tax Assessment Lookup tool. If I click on that tool, and I click on the little tool that opens up here, what I'll see is I'll get a dialog box that asks me for an X and Y coordinate location. So fortunately for me, it pre-populated with something I used before, but it's asking me for my X and Y location, which I could have grabbed from that service I showed you before with geocoding. And I can add in my spatial reference if I'd like to, and I can run that result, or I can run that process. And in my results, I can see I should see the tax assessment data come back. Did I lose my connection? Let me try that one more time. It's spinning here, up at the top. And hopefully this should populate. I'm having a little bit of a technical difficulty with ArcMap, but hopefully you're getting a demonstration of the functionality that we hope comes through. So I apologize if this is not working. I think ArcMap is reporting a bug back to me. I will mention that this tax assessment tool is only available in ArcMap because the custom tools that you get with ArcMap are not going to work in a QGIS environment. So again, the input is a X and Y location, and it would return that data set, that wealth of information that's behind it. I'm going to jump to our services again, and I'm going to demonstrate it inside here. And so inside the services layer, we have that tax assessment tool. I can see that it's the only layer, and if I again scroll down to the very bottom, like before, I can see that that execute task is the only Esri supported operation that I have. And what I can do is I can paste in my X and Y coordinates, and you can have a X colon preceding your X coordinate and a Y colon preceding, and it'll work both ways. And I can put in that spatial reference even though it's optional. And if I execute the task, this is that type of data that's also going to come up in ArcMap. I get the county where the point is located, and I get all of the assessment data available for that specific parcel where that intersection is occurring. I can change the format that I get this output in if I prefer JSON or something else. And I can even use this URL in my custom code, whether I'm using JavaScript or Python or something else to make that connection and run those queries. So for me, I'm going to summarize by saying, you know, we have these framework data sets available. And the idea behind web services is they make it easy to use data, and they remove a dependency for the downloads. So hopefully these services, especially this new tax assessment service that we've been working on, is going to be a great use for you guys. And now I'm going to hand it off to Sean to talk a little bit about this cool stuff that his group has been working on.
All right, thanks, Scott. Appreciate it. Appreciate Razzie getting everything ready. And thanks for everybody tuning in. I'm going to go over elevation and the services that we put out for it. Just a brief thing about elevation. You know, most people, when they hear LiDAR, they think about digital elevation models and contours and the raw point clouds. So just as a quick thing, you know, we get it in as classified tiles of LAS. They look like this. And then to make a digital bare earth elevation model, we end up filtering out all of the unclassified points, which are the gray ones here. We also filter out water, bridges, things like that. And you get only the ground points. And then from this, we create a digital elevation model, which will be a raster image, which you can do all sorts of analysis on, which I'll go over a little bit of. And you can make contours and other products from it. I just actually hit the wrong button on the computer. Give me a second here. Just want to go over the GIS Program Office elevation page. hoping you guys can still see my screen here. So if you go to the clearinghouse, you can go to data elevation. And from here, you can get a lot of different information. But I just want to mostly go over on here. You can go to LiDAR coverage, and you have these interactive maps. You can actually download these. They're PDFs. It'll tell you where data is available. You can also hit this LiDAR metadata link here, and it'll bring you to each project's metadata. Besides that, we also have the same thing for where our DEM footprints are. And then besides those maps, though, you can go to web services. And similar to what Scott was showing you, I'm going to show you another server connection here. It's for our elevation. So you can just copy this, and you can go into ArcMap. I'm just going to take out Scott's stuff here. And just like Scott did, I'm going to connect to another ArcGIS server. And you just paste in that link. And as you can see, when you expand that, you get a lot of different choices here for elevation.
I can't see our screen.
Hold on one second. Gonna
get back into the presentation.
Yeah. Not in here, right?
No, we got booted from the website.
All right, give me 1 second. I can't share my screen right now. So while this is getting set up, I'm just going to go over a couple of things what I'm going to show you. I'm going to go over map services and feature services. For elevation, we have them as tile indexes for the LiDAR data, for instance. Besides that, ArcMap and Esri also have image services. And that's what these DEM digital elevation models are. And we put those out. And instead of having to download the data, you can actually run a lot of analysis right through the server on these image services. Some of the things that you can do, you can clip the data and use it locally. If you have extensions like 3D Analyst or Spatial Analyst, and I think you guys can see my screen now. So like what I was saying earlier, just to backtrack a little bit, I copied this link from the web service on the elevation page. And just to go over it real quick, on these tabs here is the maps. And like I said, they're PDFs you can download, and actually they're smart PDFs. You can turn on and off layers. But so if you take that and you copy and paste it into our catalog to connect to a server, which I just did earlier, but you couldn't see. So it's just the same process that Scott did, but this one's our elevation server. So as you can see, there's all these different choices. And this blue tiled thing here, this is an image service. This green screen here is just a map service. And then a green screen with this little extra box here is a feature service. And if you forget about those, that's fine. You can actually right-click on each and go to Properties, and it'll tell you exactly what they are. But first I'm going to go over a map service. They're a little quicker. They're a little more universal. You can bring it into most programs. It's also going to, it's going to draw quicker. They have less functionality, though, as I'm going to demonstrate here. So as an example, this is our LAS indexes tile grids. And the projection's a little wonky. I'm going to just start another ArcMap session here. But so from these, since it's a map service, you can't really edit a lot. But what you can do, you can actually identify, and it'll be prompted with the attributes of the tile. And so say you zoomed into your area of interest, and you hit info on where you're trying to work, you actually get these. And so if you're looking for the LAS raw point clouds, you would load this service, and you could see this direct download link here. And you can actually click that, and you'll be prompted with a download for a LAS file. You can also copy and paste that into a browser. If you're looking to download like a wholesale or a lot of tiles or a whole project, we recommend FTP clients. While this other ArcMap loads up, I'm just going to show you. So that's a map service, and like I said, you can't change symbology, you can't really make selections, you can just identify. But with a feature service, you get a little more added functionality. So I'm going back to that elevation server, and now this time I'm going to load the DEM indexes. It's going to look very similar to LAS indexes, but these are for the DEM files that we've made. So you can do the same thing. You can hit identify, and you get prompted with the attribute table, and you can download the DEM files. But besides that, since it's a feature service, I'm just going to turn a few of these off for now, so it loads a little quicker. But besides that, as you can see, I actually have some added functionality in here. I can click here and I can change symbology. I could actually open it up. It's basically like having all the abilities if it was local. So that's one big important difference between feature service and map service. So besides changing symbology, I can go in here, I can create labels, I can do a definition query. So you're only looking for certain year elevation models or LiDAR data. You can query it on 2017 and later. And besides that, though, you can also make a selection, you can open the attribute table, and you can export it locally, where you won't have all those functions with a map service. Now, to go over image service, it's kind of similar in the respect that it has the same abilities as if it was local. So actually, I'm bringing in this image service, but just to go over something, say you don't know what project you're looking for as I go through these things in our catalog. You can actually load, we have a DEM extents map service. And so this is just all the footprints for every image service we have. And so say I was working in Schoharie County, I could just hit identify, and only one project returns here, for instance, and it's called USGS Schoharie 2014. So I know that's the image service I want to load. So I brought that in, and our DEMs look something like this. Now what it is, it's per project, we take all of those DEM tiles and we mosaic them together to get this. So that way, we're kind of skipping the step for you guys to have to download all the tiles. Usually most people want to mosaic them together to their town or area of interest and then have to run analysis on that. But here you can just kind of skip all the steps, and we have them available to you. All you need is an internet connection. So like I was saying, since this is an image service, you have a lot of functionalities. Just to go over what a DEM, this is what a DEM looks like. All the white areas are higher elevation, and when you click info on it, you actually get the elevation in meters, and all the darker areas, as you can see, are in lower elevations. So besides that, since it's an image service, you can run all sorts of tools against it. For instance, clips. Say I wanted to clip it to my area of interest, just the village of Schoharie. You can just run pretty much any tools you want. You just put in the image service as your input raster, and you put your extents or whatever your area of interest is, say something like the village of Schoharie, and then you could actually clip it and you'll export it to your local, and you can have it there for whatever you want. Now, besides normal tools like that, if you have the extensions for 3D analyst and spatial analyst, like I do have here, you have even more functionality. An example would be a lot of people like contours, for instance. That's one of our most popular products. So you can actually, instead of downloading our contours, you can actually take these image services and create your own contours. And it's a similar toolbox. You can just bring in the image service as an input raster, and then you give it whatever contour interval you want. We have them as 2 foot, for instance, but you can put in whatever you want here, and you can create contours that way. Another cool thing is called a view shed. And this takes a little while to run, so I'm just going to show you what the inputs are like. And then I have something preloaded I'll show you. But you can put the image service as the input raster once again. You can put a point or a line in as your observation area, and then you get an output. And it'll look something like this. So for instance, I had this one observation point, if you will, and this is the village of Schoharie here. And I ran it against the only the village against this image service, and you get something that looks like this. And you could overlay this on, imagery or like a hillshade or on these DEMS. What you're actually seeing here, and actually I'm going to bring in the hillshade right now, and I'll go over that a little bit more, but it'll make this pop out a little better. You can put a transparency on it, this view shed that you've created. And you can see all the green areas from this point in the middle here. All the green areas are places you can see, whereas the orange, they're either too high or too steep and out of your observation point to see. Besides that, you can actually, if you have the 3D Analyst, you can turn on the 3D Analyst toolbar. And for instance, you can zoom into an area. I'm going to turn this off now. And you can do this thing called Create Line of Sight. And you could start from the top of a hill, go across a valley, for instance, and a line should get created. Oh, I have to have the digital elevation model on, sorry. So let me make this a little transparent here. Make this one transparent, sorry about that. And like I said, you can take this create line of sight, start from the top of a hill, and go across. It seems to not be working right now. But basically, you get a profile line graph of the areas that you can see. Besides that, you can also do something very useful. Say you have a bunch of points of interest that you have in that intersect one of our image services. So for instance, I have about these 10 points here. And what you can do is you can do this thing called Add Surface Information. And what this will do is you'll use the input surface as this image service that I've been talking about. In the last couple tools, it's been the input raster. In this case, it's the input service. And then you can bring in your points of interest. And what will happen, it's going to give you a Z value in meters in this case for all of the points. And hopefully it doesn't take too long to run. But while that does go, just to go over quickly about our hillshade service. So we put out the hillshade service as a statewide data set. And it comes in 1 meter and 2 meter resolutions. And then to fill in the gaps, we have a USGS 10 meters. And this is a map service, so you can bring it into a lot of other applications. You can't really run analysis on it. It's more for just display. And as you can see, the elevations and the slopes and everything really pop out with this hillshade. You can actually download our DEMS, or you can even apply a hillshade to our image services as well. But just to show you, that other tool stopped running. So now what I have is Z values for all of these points that I put as the input. And what you could do actually, so this is in meters, you could add another field and calculate it to feet. It's very useful. Now besides that, that's just kind of some ArcMap functionality. I just want to go over also a little bit in QGIS. So like Scott did, you can add layer, and you can do a map service or a feature service. But for instance, as you can see here, there's no image service. Now, what you can do is if you go back to, for instance, the REST endpoint page, but for the elevation services. It looks a lot like what Scott had up earlier. You can click on an image service, for an example, and we make all ours available as also a WMS. So if you click on WMS, you can actually take that whole link, and QGIS actually has an add layer for a WMS. And you can bring this in, for instance, just like how Scott did. So this time it's a WMS. Hit OK, and then connect. And you get this. You can pick different file formats here. That just closed out. But when you bring it in, you're actually able to see the whole image service. There we go. Add. But the problem is, since it's an Esri image service, you actually lose a lot of those functionalities. You're not going to be able to run a lot of the tools. But say you just needed it in your map, you can display it in QGIS. Another quick thing, we get a lot of people asking about our contours. So just to go back to the clearinghouse real quick, on these at the elevation page, you can go to our high resolution contours. So say you're looking for LiDAR data, but you don't need the raw point clouds and you don't need the DEMS. We've actually already made contours for, as you can see, most of the counties in the state. All the orange ones we've made, the other colored counties, it'll bring you to like a county website and the county supplies those contours. They've made them. But just sticking with our Schoharie example, if you click on this interactive map, you get brought to, it'll show you what the extent of the contours look like, and then you can hit download this contour zip file. When you download the zip file, it's going to look like this. It'll be just a folder. For instance, it'll be each county. Within that folder, though, once you unzip it, you'll have a GDB and a layer file. Now, the layer file you can bring into ArcMap, and you can, it'll be scale triggered. We break it by 2 foot, 10 foot, 20 foot, 100 foot, 250 foot, and 500 foot contours. And, as you zoom in, the 500 foot and higher ones turn off. As you get closer and closer, the 2 foot ones turn on. And for instance, say though you didn't have ArcMap and you still just wanted the contours, you can actually bring these into QGIS by going to Layer, Add Layer, a Vector Layer since it's contour lines. And since it's a GDB, you actually are going to a directory. And if you browse to wherever you've downloaded those contours, you actually click on the GDB. You don't want to go within that. So QGIS is kind of reading the GDB as a, a folder. And you can add that. And you get a choice of, as I said, how we break out our contours within interval feature classes. So I'm just going to do the 100 foot because I know it's going to go a little quicker. But you can add those. Okay. I might have just done it twice. And so as you can see, they're in here. But with using QGIS, and since it's a free software, and if you don't have ArcGIS, you can just download QGIS for free, take our contours, and you can actually simply export, and you save feature as, and you can change it from an Esri file geodatabase or a feature class to a lot of different choices. You get Esri shape files, you get CAD DXF files, you can even do KML and bring it right into Google Map or Google Earth. And yeah, so that's pretty much it. So just to wrap it up, we went over the differences of LAS and DEM and contours, the different functionalities of a map service and a feature service, and that you can use QGIS for free, and you can change the file extensions and stuff with that. So I think I'm going to turn it over to Razzie for maybe taking questions for me and Scott.
Excellent. Thanks, Scott and Sean. I want to thank you guys for excellent, informative, presentation. Tons of tools and services that the GPO offers is really, really fascinating and great stuff that you guys have been able to put together there. And I want to also thank our attendees. We went through a little technical difficulties, but they're riding strong and they've really lasted throughout the presentation. How much interest everyone had for this. So I want to just reiterate, we have recorded this webinar. This will be made available so you can check back, and it'll be ready hopefully soon on our website. We are in the Q&A portion of our presentation. I do have questions already waiting in the queue. For anyone else, please send in those questions. We will go through each question one by one. I'll read the question out loud and then allow time for Scott and Sean to answer the question. Send those questions in. If you're able to send in the question but unable to stay for the duration, again, since we have this recorded, this will be made available once we go through. So the first question, what is the HTTPS link to the server?
Okay. Let me pull up that slide for you. So there's our service link. You should see that right at the top there, HTTPS. This is the GIS services box. Sean's box is a little different for the orthoimagery. Yeah. I can bring that up there as well too.
Yeah, if you're on the GIS Clearinghouse and you go to Web Services, you get actually even more choices than what me and Scott have talked about. The one Scott was kind of connecting to is just kind of, your base data and a couple of geoprocessing tools like the locator and the tax assessment thing he showed you. But you can connect to the elevation one for more of the DEM image services and then those tile indexes.
I'm gonna get to that. I just had to reload the thing for a second here. I'm gonna put up the gis.ny.gov spot that Sean's talking about. So specifically off of gis.ny.gov, we were talking about the web services available. You could hit up either the imagery and elevation folder or the non-orthophotography one. And in each of those links, you're going to see that HTTPS or HTTP URL that you're going to need.
Yeah. There's multiple servers. You'll have one for orthoimagery, one for elevation, and another one that has the other stuff that Scott was showing.
Let me make sure people can see that. All right. Maybe you didn't see that. So again, that was just getting to off of the gis.ny.gov, share.js, web services, and down here you'll have the two folder choices. Each one will have that URL that you're going to need.
Razi, you still there?
Yeah, excellent. I was just making sure you guys completed that. Next questions. Yes, we are having the webinar. The webinar has been recorded, and it will be shared via the membership in terms of notices that it's been up. I would check in about a week or so, maybe after the New Year's, just in case we're not able to get it up. But we're going to try to get this webinar up to our website as soon as possible, so everybody can really dig into it and get going with services. The next question we have: can we download your merged DEMs or merge last point clouds?
All right, yeah. So for the LAS point clouds, you can download them tile by tile the way I showed you, or like I said, we recommend a FTP client. So like FileZilla or WinFCP, those are free. You can download them. You can go in there and you can connect to our FTP, and you can download them bulk. But as far as the DEM data sets, you can also do the same thing. But like what I was showing you with the image services, you could just bring in an image service, and you could clip it to whatever, and you could download your area of interest from that. Or, with the image services, technically you don't even need to do that. You could run a lot of analysis just on the image service itself.
Excellent. So I don't see any further questions at this time. I'll give the audience maybe 15, 20 seconds if any additional questions are yet to come in. Okay. Looks like we're all set with the questions. Again, Scott and Sean, I want to thank you, the two of you, for an excellent presentation and going through all these tools and services that the GPO offers, and appreciate your patience with the technical difficulties we had. As well as I want to thank the audience and our attendees. If everyone can show some love to our presenters, please do so in the chat box. Appreciate everyone again for being part of this. And if you're not a member of the New York State GIS Association, please consider doing so. It's only $10. Really helps us, support these type of services. Looking ahead, we have a couple of webinars as the new year turns around, and keep posted with the webinar series as part of the association. Before we close out, Scott and Sean, would you like to say anything before we wrap up?
No, but I know me and Scott are just, we have our email addresses up here. If you have any questions, you can contact us through that.
Yeah, please do.
And thank you again, Scott and Sean. Thank the GPO for an excellent presentation, and thank everyone in the audience. Enjoy the break, everyone, and until next time, have a good one. Thank you very much.